In the vast tapestry of scientific discovery, there are threads woven with brilliance, innovation, and profound insight. But sometimes these threads are stained with a deeper, more somber hue, the tragic cost of being ahead of one's time. Imagine a mind so incandescent, so revolutionary that its very ideas challenged the bedrock of established thought. A mind that sought to unveil the invisible machinery of the universe, only to be met with scorn, isolation, and an almost unbearable weight of intellectual resistance. This is the story of Ludwig Boltzmann, a physicist whose genius illuminated the atomic world, but whose personal journey descended into a profound darkness, making him perhaps the most tragic figure in the annals of science. His pursuit of truth came at an unbearable price. Born in Vienna in 1844, Ludwig Boltzmann emerged into a world on the cusp of radical transformation. The Industrial Revolution was in full swing, and physics, dominated by the elegant certainties of Newtonian mechanics, seemed to have most of the answers. Yet, new phenomena, particularly those running heat and energy, were beginning to push the boundaries of classical understanding. Thermodynamics, the study of heat and its relation to other forms of energy, was a burgeoning field. Scientists like Rudolf Clausius and Lord Kelvin had laid foundational principles, introducing concepts like entropy, a measure of disorder. But the underlying nature of heat, its microscopic origins, remained largely a mystery. From an early age, Boltzmann displayed an extraordinary intellect. He studied mathematics and physics at the University of Vienna, quickly distinguishing himself. He was a brilliant lecturer, charismatic and passionate, captivating students with his dynamic explanations. But his true genius lay in his ability to see beyond the macroscopic, to envision a hidden reality. Boltzmann's groundbreaking insight was audacious for its time. He proposed that the macroscopic properties of gases, their temperature, pressure, and volume, were merely the average behavior of countless tiny, invisible particles, atoms and molecules, constantly in motion. This was the birth of statistical mechanics. His most famous contribution, the Boltzmann equation, provided a statistical description of the dynamics of a gas, showing how systems evolve towards equilibrium. He linked entropy, he measure of disorder, to the number of possible microscopic arrangements of these particles. The ways particles could be arranged to produce the same macroscopic state, the higher the entropy. This equation Sk log W, where S is entropy, K is Boltzmann's constant, and W is the number of microstates, was revolutionary. It provided a statistical, rather than absolute, definition of entropy, suggesting that the universe tends towards greater disorder because there are simply more ways for things to be disordered. But here lay the crux of his tragedy. To accept Boltzmann's work, one had to accept the reality of atoms, entities too small to be seen, felt, or directly measured with the technology of the late 19th century. And many prominent scientists simply refused. The intellectual climate was hostile. Leading figures like Austrian physicist Ernst Mach, a staunch empiricist, argued that science should only concern itself with observable phenomena. Atoms, to Mach, were metaphysical constructs, unproven and unnecessary hypotheses. German chemist Wilhelm Ostwald, another powerful voice, championed energeticism, a philosophy that sought to explain everything in terms of energy transformations without recourse to invisible particles. He saw Boltzmann's atomic theory as a regression to outdated materialism. Boltzmann found himself in a relentless intellectual battle. He was ridiculed, his work dismissed as mere speculation. His colleagues questioned his sanity, his methods, and the very foundation of his theories. He moved from university to university across Europe, seeking an environment where his ideas might be better received. But the skepticism followed him like a shadow. He engaged in furious debates, writing extensive papers defending his work, often with a biting wit that only further alienated his opponents. But the constant intellectual combat, the feeling of being misunderstood and marginalized, began to take a heavy toll. The relentless opposition eroded Boltzmann's spirit. His once vibrant lectures became tinged with melancholy, his arguments laced with a wariness born of ceaseless struggle. He suffered from severe mood swings, periods of deep depression alternating with fleeting moments of manic energy. His health deteriorated. The very concept he championed, entropy, the universe's inherent tendency towards disorder, seemed to mirror his own internal state. His structured, brilliant mind was being assailed by chaos of rejection and misunderstanding. He felt like a lone voice shouting into a void. Despite the support of his family and a few loyal students, the isolation was profound. He was a visionary without a receptive audience, a prophet in a land of disbelievers. The weight of his intellectual solitude became unbearable. He had dedicated his life to a truth that the scientific establishment refused to acknowledge. In the summer of 1906, while on holiday with his family near Trieste, Italy, Ludwig Boltzmann reached his breaking point. On September 5, 1906, Ludwig Boltzmann took his own life. He hanged himself during a moment when his wife and daughters were away swimming. The man who had unlocked the secrets of the atom, who had given us a fundamental understanding of the universe's microscopic dance, succumbed to the immense pressure and despair of his unacknowledged genius. The irony is tragically profound. Within a few years of his death, the scientific world began to shift dramatically. Albert Einstein's 1905 papers on Brownian motion provided irrefutable evidence for the existence of atoms, precisely as Boltzmann had predicted. Max Planck's work on quantum theory further validated statistical mechanics. Jean Perrin's meticulous experiments confirmed the atomic theory beyond any reasonable doubt, earning him the Nobel Prize in 1926. Suddenly, Boltzmann's metaphysical constructs became the bedrock of modern physics. His work was not just correct, it was foundational, indispensable. Today, Boltzmann's constant, his equation, and his statistical interpretation of entropy are cornerstones of thermodynamics, statistical mechanics, and even information theory. He is recognized as one of the most brilliant and influential physicists of all time. His legacy is etched into the very fabric of our understanding of matter, energy, and the universe itself. Ludwig Boltzmann's life serves as a poignant reminder of the human cost of intellectual revolution. He fought battles not just with equations and theories, but with the entrenched dogmas and biases of his era. He saw a truth that others could not, or would not accept, and paid the ultimate price for his foresight. His story compels us to reflect on the nature of scientific progress, how often the greatest leaps forward are initially met with resistance, how easily genius can be overlooked or actively suppressed. It underscores the importance of open-mindedness, critical thinking, and the courage to challenge established paradigms, even when the evidence is not yet visible to the naked eye. Boltzmann's work helped us understand the universe's tendency towards disorder, yet his own life was a testament to the profound disorder that human misunderstanding can inflict. His tragedy is a powerful testament to the fragile line between brilliance and despair, and a timeless plea for empathy in the pursuit of truth. His spirit, however, lives on, not in sorrow, but in every atom, every molecule, and every fundamental law of the universe he so bravely sought to understand. Thank you for watching our video. Don't forget to like and subscribe. We value your thoughts greatly. Let us know in the comments.